Hi guys, in May you are analyzing the company's revenue over the last 10 years. Year after year, the revenue keep increasing. Now here the questions. Is the company adding the same amount of revenue every year, or it is growing at the same percentage rate every year? Those may sound similar, but they are not. And choosing the wrong trend model can completely change your forecast and your investment decisions. This is exactly why financial analysis economists need to understand the difference between linear trend model and log linear trend model. Today we are going to learn not just the formulas but how professionals decide which model to use, why financial data often prefer one over the other, and why trend models eventually break down in the real world. Let's dive in. So let's begin with the foundations. A time series is simply a sequence of observations collected over time. The key difference between time series data and most other datasets is that observations are naturally ordered. Time matters. So for example, image recording Apple's annual revenue, monthly inflation, daily exchange rate, or quarterly GDP. Each observation depends on when it was measured. Now, why do analysts care so much about time series? Because we rarely interested only in the past. We want to understand where things are going. We want to identify trends. Forecast future values, estimate growth, and make better investment decisions. So whenever we work with time series, one of the first questions we ask is there a trend? In other words, does the variable generally move upward, move downward, or stay relatively flat over time? The easiest way to answer that question is surprisingly simple. Plot the data. Professionals almost always begin with the chart before running any statistical model because many important patterns become obvious visually. So now, suppose your data increase by roughly the same amount every year. Think about a company that earned an additional $10 million in revenue each year. Year 1 increased by 10 millions, year 2 increased by another 10 millions, and year 3 another 10 millions. Notice something important. The increase is measured in dollar, not percentage. That is exactly what a linear trend model assumes. The model says the variable changes by a constant amount every period. Mathematically, we write it as. So let's understand each component. The intercept P0 is where the trend begins. The slope P1 tells us how much the variable changes every period. If the P1 is positive, the trend moves upward. If it's negative, the trend declines. Think of the slope as the speed of the trend. A larger slope means the faster linear growth. A smaller slope means slower growth. The key phrase to remember is constant absolute change, not constant growth rate, constant increase in actual units. Of course, real-world data almost never form perfectly on straight line. Some observations lie above trend, others form below it. Those different are called residual or predictions error. So how do we estimate the best trend line? We use ordinary least square or OLS regressions. OLS search for the line that minimize the sum of square residual. Why square the residual? Because large mistakes should be penalized more heavily than the small ones. Once OLS estimate the intercept and slope, we obtain the fixed trend equations. Now we can estimate the expected value of the variable at any point in time. This is the same regression technique you already seen in many quantitative methods. The only difference here is that the independent variable is simply time. So here, where finance becomes interesting, most financial variables don't grow by a fixed amount. Instead, they grow by a fixed percentage. Think about investing. If your portfolio earns 10% annually, the dollar gains become larger every year because the investment base keeps growing. That's compound growth. The same idea applies to company earnings, sales, GDP, populations. Many economic variables grow proportionally, not linear. So instead of adding the same amount every period, they multiply. This means a straight line no longer describes the data very well. Instead, the data begin to curve upward, and that's exactly when analysts switch to a different model. Suppose a company's revenue grows 5% every year. The increase in dollar terms become larger over time. This creates a exponential growth pattern. Mathematically, we write it as. At first glance, this looks difficult. Fortunately, there's a simple trick. Take the natural logarithm of both sides, the exponential disappears, and suddenly our curve relationship becomes a straight line. So the model will becomes. That's why it's called a log linear trend model. The regression is linear, but it's linear in the logarithm of the dependent variable. Here's the key intuitions. Instead of assuming a constant dollar increase, now we assume a constant percentage growth rate. This is much closer to how business investment and economies actually evolve. Now comes one of the more practical questions. How do professionals decide which model to use? The answer begins with visualizations. First, fix a linear trend, then examine the residual. If the residuals are scattered randomly above and below the trend line, that's a good sign. The linear model is probably appropriate, but suppose the residuals stay positive for several consecutive years, then negative for several years, then positive again. That pattern is not random. It tells us the straight line is systematically missing something. Very often, the missing feature is exponential growth. The solution is to transform the dependent variable using the natural logarithm. Run the regressions again. If the residual not appear randomly distributed around the fixed line, the log linear model is likely a better choice. Professionals don't choose model because one formula looks sophisticated. They choose the model that best explains the behavior of the data. Now let's discuss some things. Trend models are useful, but they have the important limitations. One fundamental assumption of linear regressions is that residuals are dependent. In other words, today's predictions error should not depend on yesterday's predictions error. Unfortunately, financial time series rarely behave that way, making have momentum. Economic cycle persists. Company performance often carries over from one period to the next. As the result, the residuals frequently become serially correlated. This means consecutive errors tend to move together. When serial correlations exist, many statistical properties of the regressions become unreliable. More importantly, future values depend not only on time, but also on previous observations. That's why trend models alone are generally poor forecasting tools for financial time series. Professional forecasting often rely on auto-regressive model, where past value help predict future value directly. Trend models are excellent for understanding long-run directions, but they are usually not the final forecasting model. So if you can distinguish constant absolute growth from constant percentage growth, understand when to use each model and recognize their limitations, you are master one of the core quantitative concepts. Thanks for watching.